Hello everyone, I welcome you all to this class. This is mathematics class and today we are here again to consider another important topic, line integral. Now in this video I will show you how to perform line integral. When I'm talking about line integral, I'm talking about integral along a specific curve. Along a curve. Integral, when you are evaluating integration along a curve, it is called what? Line integral. This curve could be a circle, it could be a rectangle. So depending on the curve, the nature of the curve, so you can evaluate the line integral. In this question, they asked us to evaluate this given line integral. Integral over c of f bar dot dr. Our f is this vector given. So this is the vector given to us, and we are evaluating this line integral from the point 0, 0, 0 to 1, 1, 1 along the curve x is equals to t, y is equals to t squared, and z is equals to t raised to power 3. So with this we can proceed to solving the problem. So let's write what our vector the r will be. So because we are having ijk components, right? Ij components, the r will be the xi plus the yj plus the zk. If you have only ij components of this vector, your dr will be the xi plus the yj. In this integral, we need to do f bar dot dr, right? So what is our f bar dot dr bar? So the r is a vector. It has ijk component. So we are going to dot it with this f. So I component will multiply the I component. So let me write this. So we have 2x plus 3y squared multiplying the I component there. Here is I component, here is the x, plus, so the j component here will multiply j component here. J component here is 8yz, multiply the j component here, dy, plus k component here will multiply k component there. K component here is 10x z squared, multiply the k component here, dz. So I've gotten this. So we are evaluating this line integral from this point to this point along the curve. X is equals to t, y is equals to t squared, and z is equals to t raised to power 3. Actually, this curve you are evaluating it along is a straight line. They have already written the parametric equation of the straight line. So they have written the x in terms of t, y in terms of t, and z in terms of t. So there is your x, y, z. They are already in terms of one parameter t, and we are evaluating it from this point to this point. So this is actually a straight line, your curve. We can substitute x for t, substitute y for t squared, and substitute z for t raised to power 3. Not only that, we need to get what our dx will be, our dy will be, and what our dz will be. Since they gave us that x is equals to t from what is given to us, it implies that if you differentiate x with respect to t, you are going to get what? You are going to get, differentiate x with respect to t. If you differentiate t, you get 1, right? So, and if you multiply both sides by the t, that's making the x the subject, you are going to get that the x is equals to 1 times the t, that's the t. So I've gotten what I'll substitute for the x here, that the x is same thing as the t. And we are also given that y is equals to t squared. Y equals t squared implies that the y, the t, differentiating y with respect to t. If you differentiate t squared, you get what? 2t. And if you multiply both sides by the t, you are going to make the y the subject, and the y will be equals to 2t dt. If you multiply both sides by the t, so which means that I will substitute the y for 2t dt. Then we are also given that z from here We are given that z is equals to t raised to power 3. And this implies that if I differentiate z with respect to t, what will I get? If I differentiate t raised to power 3, so I'll get 3t squared. And this implies if I multiply both sides by the t, I will make the z the subject, and the z will be equal to 3t squared dt. So this is what I will have. I'll have this 3t squared dt. So I've gotten the x, the y, the z in terms of the t. So I know my x, I know my y, I know my z from what is given to us. So we can easily substitute. So, but before that, let's write the range of t. You can use any, since the equation is already parameterized, you can use any of the parametric equation to get the range of t. We are given x is equals to what? T. You know, in this point, the first component is x. So first component here is x, which is also the same thing as first component here, x. So x is 0 at the first point, and x is 1 at the second point. So, and we are given that x is equals to t. So if x becomes 0, if you put 0 here, t will also become 0. And if x becomes 1, t will also become 1. So you can use 1 to do that. If you go to y2 to analyze the same thing, you get the same results. If you go to z, you get the same result. So which means that t will lie between 0 and 1. T will lie between 0 and 1. So we are going to perform the integration in terms of t. So I've written f bar dot dr. You know, they told us to evaluate integral over c of f bar dot dr. So, and we have evaluated f bar dot dr. So we just do integral over c, and we now copy this, what we got there, and put it here. So our curve now, I will remove this c now, and I'll put the range from 0 to 1 for t. So, and we have written down our integral over c of f bar dot dr. So this is what we have gotten, and we are given from the equation that x is equals to t. So we are going to come here, we replace x with what? T. So here will be 2t plus, they gave us that y is equals to t squared. So here we are having 3y squared, and y is already t squared. So if you do y squared, so we are given that y is equals to t squared, but y is squared here, so it means it's t squared all squared, which is t raised to power 4 multiplying 3, right? So you are going to have 3t raised to power 4. Then we have already gotten that this dx, I've gotten it, the x is the same thing as what? Dt. So I'll put the t here. I'll put the t here. Then plus, for this place now, we have 8yz. We have 8y is t squared, right? From what is given to us. What is z? Z is t raised to power 3. T raised to power 3. So if you do t squared multiply t raised to power 3, you add the index of t, you are going to get t raised to power 5. Then multiply 8, you have 8t raised to power 5. But what is dy? Because this 8yz is multiplying dy. Dy, we got it dy to be 2t dt. So we are going to multiply this by 2t dt, right? So if you multiply it by 2t dt, what will you get? You will now have 2 multiply 8, you have 16. And t multiply t raised to power 5, you have t raised to power 6. So this will be t raised to power 6 dt. Then for the other one, for the last part, we have 10xz squared. But what is x? X is t from what is given to us. What is z squared? Sorry, what is z? Z is t raised to power 3. That's our z from what is given to us. But you are having z squared, which means t raised to power 3 raised to power 2. So what will this give you? By the law of indices, you multiply the power of this t. So I'm going to have 10 multiplying t, multiplying, if you do 3 multiply 2, you have 6, right? You have 6. So if you now do 10 multiplying t raised to power 6, you are going to get what? 10 t raised to power what? 7. You are going to get 10 t raised to power 7. That's what you are going to get. But this 10x z squared is multiplying dz. It's multiplying dz. What's our dz? Our dz is 3t squared dt. That's from this place we got is 3t squared dt. So if you do the multiplication all together, 3 times 10 will give you 30, and t square multiplying t raised to power 7, we have t raised to power what? 9. If you add index of t, then the t. So we are going to have here plus 30 t raised to power 9 dt. So from this one, we have integral from 0 to 1. Dt can come out because dt is now common. Dt can come out. We now have 2t plus 3t raised to power 4 plus 16t raised to power 6 plus 30t raised to power 9, then dt. So if you integrate this, if you integrate 2t, you are going to have 2t. You add one to the index. That's 2t raised to power 2 divided by 2, right? Plus, if you integrate 3t raised to power 4, 3t raised to power, you have to add. If you are doing the integration, you add 1 to the index. If you add 1 to 4, what will you get? 5. T raised to power 5. Then you bring down that index, 5. Plus, we have 16t. So you add 1 to this index. Index is 6. Add 1 to 6, you have 7. You divide by that result. Divide by 7. Plus 30t. Add 1 to this index. Index is 9. Add 1, you have 10. Divide by the result, 10. So evaluated, what's the range of our integration? Range is from 0 to 1. That's the range of the integration. So let's put our first range. Our first range is what? 1. So anywhere you see t here, replace t with 1. So if you put 1 here, you are going to have 1 squared is still 1. So you are going to basically be having 2 over 2 here. Plus, come here, put 1 for t raised to power 5. 1 raised to power 5 is still 1. So you'll be having 3 over 5 left. 3 over 5. Plus, for this place, if you put t for 1 here, 1 raised to power 7 is 1. So you'll basically be having 16 over 7 left for that one. And for the other one, put 1 for t here. 1 raised to power 10 is still 1. So we basically be having 30 divided by 10 left. But if you put the lower range is what? 0. If you put t for 0 here, this will go 0. Put t for 0 here, this will go 0. Put t for 0 here, this will go 0. Put t for 0 here, this will go 0. So the lower range will be 0. So the lower range will be 0. So minus the lower range, 0, right? So let's divide. 2 divide 2, 1. Plus 3 over 5. Plus 16 over 7. Plus 30 divide 10. You have 3, right? So this is what we have. And if you want to find it as a single this thing, you the we think of the LCM. So we can leave our answer like this. Thank you so much for being part of this class. We are going to solve more example on this topic. Thank you so much. Bye.